No. Good morning everyone, and a very warm welcome back to the channel. And welcome back once again to our comprehensive CNC lathe programming course. Today, in this session, we are going to look at two important things. So I should warn you in advance that the video might be a bit long. What we will be covering in detail is the fixed cycle macro for both external and internal roughing, which is extremely useful for clearing out more complex profiles. We will also approach the simulator to provide a practical hands-on example of what we will do. So the first part will be on the whiteboard, and the second part will be on the FANUC simulator. I chose FANUC over Simes because FANUC supports macros, unlike Simes, which doesn't due to settings issues. I prefer Simes for conversational programming, which we'll discuss later. Today we're focusing on the roughing macro, also called fixed cycles in manuals. I apologize for not distinguishing them. Previously we explored clearing apart with point-to-point programming. Now, on the whiteboard, I want to explain a macros concept. Consider a piece like this. We're not focusing on dimensions now, but after facing it, we have material left to clear. Today we're talking about the roughing macro. I call it a macro, but in the manuals they refer to it as fixed cycles. So I apologize for not making that distinction. We've already seen something in the previous video regarding the possibility of clearing a part with point-to-point programming. Now, what I want to show you on the whiteboard, more than the program itself, is the concept of how a macro works. Let's take a piece like this. Okay, we're not concerned with the dimensions at the moment. And let's say that after we've faced it, we have all this material left to clear out first. To execute the profile from point A, B, C, D, E, F, from point A to point F. Now we know very well, we've done it, we've seen it in previous tutorials, that point by point we can make a certain number of passes and then describe the profile. It's true that in some places, especially where there are angled profiles, knowing exactly where to stop forces us to do a couple of calculations or to pay a bit more attention. So what does the roughing macro? She reads the profile and then she does all this calculations for us. So in 2 blocks we resolve all the steps needed to empty the piece. Let's try to understand a couple of concepts first. We're going to put the various preparatory functions into our program. What are the preparatory functions? We've already mentioned M4, spindle rotation, tool change, turret rotation, speed limitations, and so on. After that, we need to think about this profile. So, what does the macro ask us? It asks us for information. Why am I telling you all this? Because whether you're working on one CNC or another, the information you need to provide is pretty much the same. So we need to give the machine an idea of the piece, let it know that we're using a macro, and then define the profile on the raw piece. So the first thing we should do is position ourselves at this point. Let's call it point alpha. Point alpha simply tells the machine where the furthest and safest edge of the piece is located. So point alpha will be for a macro that involves longitudinal machining coinciding with the outer diameter of the piece, and at 2 or 3 meters of safety in Z. At this point, we can insert our fixed cycle. Let's write fixed cycle. So, how do we identify the fixed cycle? With a G. And this G is literally saying, oh, I'm starting a macro, follow me. In this case, with G71. Then we should give depth of cut, meaning every time I make a longitudinal pass, I'll do, so I lift up, I come away, and I don't lower, and I start again. This distance, radial depth of cut. So let's call it out, depth of cut, and R for return, meaning how much I retract. Every time I come back, Fanuc provides a roughing macro in 2 lines. So below we'll find another G71, and this G71 will specify A and F, meaning where I start the profile and where I finish it, but not based on coordinates, rather on a description of the cycle that we'll find below our cycle with a series of coordinates. And there will be N10 and N20, we'll call them that. So we'll number some blocks where I'll indicate A and F, and then in between I'll find B, C, D, E. So the G71 series, C will read the first and the last, meaning it will read all the blocks between A and F. It determines the profile, leaving excess in X and Z for finishing. I'll set a single feed rate. The machine reads preparatory functions for a fixed cycle with a 5mm pass, retracting 1 mm, while following the profile between blocks 10 and 20. Then I'll specify the feed rate, which will be a single feed rate for the entire cycle, with which we'll make these passes. So, the machine will read preparatory functions, then it will say, I have a fixed cycle that I will have to do with a 5mm past return by detaching myself by 1 mm from the tool, following the profile that I will describe in the following blocks, between block 10 and now block 20. I will have to do everything at an F of 0, 3, 0, 2, 0, 4. After that, I could add at the bottom a G70, always A and F, that will tell it, well, now go and finish it. This is the logic that every lathe, every CNC will adopt when it needs to perform a roughing cycle. I'll give you a heads up, and we'll see it later that the roughing cycle can be done either longitudinal or parasitic. Pam, 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 pam can do. It can be done externally or internally. Just pay attention. We'll see later if we do it internally or externally. Even in this case, okay, the signs of the excess material change, and the signs of the excess material will follow our Cartesian axis. So if this is my finished piece, I leave some excess material in this direction. The excess material is like this, which means my U will be positive if I'm working on an interior and leave some excess material in this direction. Then my U will be negative. Afterwards, I will put a little diagram on video that I recommend you watch, read, maybe take a screenshot, and keep it. Now, have I confused you well? I hope so, because now I'm going to unconfuse you, meaning I'm going to take you to the simulator with a practical example, and you'll see that everything written in a somewhat confusing way on the board will become much, much clearer. Okay, so hold on a second while I switch to the simulator, and we'll see each other in a moment. Here we are, perfect. I've prepared a little exercise for you. As you can see here, we have a whole profile to hollow out. and a raw piece with a diameter of 130 and a length of 75 meters and a hole of 30. So what we're going to do now is work on the simulator, which you can see is a rough, I would say, nice copy of a Fanuc 31 ITD CNC. This simulator is designed to replicate the real-world operations of a CNC machine, providing a virtual environment where we can practice and perfect our skills without the risk of damaging actual equipment. We're going to face rough and finish inside and out. This process involves several steps, each requiring precision and attention to detail. Get ready, because doing this with an explanation takes a bit of time, especially since, as I mentioned in the previous video, there are two main aspects we need to focus on. First, the accuracy of our cuts, which is crucial for ensuring that the final product meets the desired specifications. Second, the efficiency of our operations, which can significantly impact the overall productivity of our machining process. By understanding these elements, you'll be better equipped to handle real-world CNC tasks. Additionally, this exercise will help you develop a deeper understanding of the machining process, allowing you to anticipate potential challenges and devise effective solutions. Remember, practice makes perfect, and the more you engage with the simulator, the more proficient you'll become in operating CNC machines. So, let's dive in and explore the intricacies of CNC machining together, step by step, ensuring that you gain the confidence and skills needed to excel in this field. Course it's to watch, 2 videos to watch on my channel on how to use the simulator. But it's not like I'm going to use it like crazy without explaining anything to you. The beauty of this simulator is that if you make even a little mistake, it will certainly not let you get away with it easily. The more attentive ones among us will have seen in my previous video. I did on the whiteboard an example of how to profile a piece by starting with G42, which stands for tool radius compensation. However, without putting G40 at its end, which you must include when there's a G42, to cancel out and negate this tool radius compensation before one can go back to rapid movement mode again safely and securely. Well, now, the whiteboard doesn't give me any errors whatsoever. Indeed, there, you can do whatever your heart desires there freely. This simulator does not forgive mistakes lightly though, and you'll see firsthand that even I myself will make quite a few mistakes, because I use about 7 or 8 different controls, each having those tiny differences that sometimes lead me into making errors inadvertently. So here we are standing right in front of our CNC machine setup. Once again today, the very first thing we need to do immediately is enter into edit mode promptly. Okay then? Edit happens to be precisely the area within CNC operations, allowing me personally as an operator to manipulate these programs effectively. Going over towards Program List View and seeing clearly, we have got our machine set up currently under Virgin configuration status. So let's proceed forward creating brand new program, calling it simply G71. Now unfortunately my keyboard seems engaged in some sort of conflict, particularly against minus key functionality. I sincerely hope therefore not too many typing mishaps occur during process, since pressing minus doesn't register properly. But rest assured I'll notice such issues during simulation phase itself eventually anyway. Let's create said program now while editing comment section thoroughly afterwards, never leaving behind any single programming instance devoid comments. Otherwise whoever comes after won't understand anything at all. Really speaking honestly here folks, for example, fixed roughing cycle description might suffice initially perhaps. Let's check whether space is accepted correctly given fact. Not every single CNC handles spaces inside comments equally well, some requiring underscores instead, possibly maybe. Opening up reveals empty little program space, ready awaiting input naturally enough. The first action course inserting necessary parameters accordingly, since discussion revolves around simulation context, specifically needing access, soft key start feature part conversational programming, yet convenient usage graphics purposes overall. Generally speaking, ultimately leading raw material insertion step, next case being specific scenario. It's a tube. We select the outer diameter. We set approximately 100. Very well. The numeric keypad breaks the balls of 130 and internal diameter. We said 30 mm, length 75. Origin of the piece, i.e. the excess metal that we should remove, so 73-75, in this case 2 meters, and we insert our rough, after which we insert. What are my initial parameters? So G92S2000. We limit the RPM to a safe level. FANUC requires a semicolon, also called EOB insert. We insert the line, we insert the gamma change. Not all lathes have it, so EOB insert, and we tell the machine G95 EOB insert. 4. Feed in millimeters per minute. I often forget G95 because I learned to program on ECS, which set it by default. So I often end up doing the whole program on the first start of the machines, and all it does is tell me, hey, you're missing a code. I remember G95. At this point, let's call to allow the simulator to work correctly, we specify the tool, find the soft key for offsets, then go to T101 for the offset. When I set machine zeros, only done in reality, we need to know the tool radius. I'm using a radius of 0.8 already set. It's already empty, only this radius of 0.8, a virtual point. This indicates the machine to use G42, meaning we're doing the outside using a rhombic insert. Let's see if I can, yes, React 0101 EOBX. To allow the simulator to work correctly, we need to tell it which tool we're talking about. So we look for the soft key for offsets. There it is. And we go to T101 to indicate this is about the offset. So when I set the machine zeros, which can only be done in reality, we need to know which tool radius we're using. Well, I'm using a radius of 0.8. This is already set. In fact, let's do something. Okay, it's already empty. There's only this radius of 0.8, a virtual point. This is an indication for the machine to use G42, meaning we're doing the outside, and we'll use a rhombic insert. Let's see if I can. Just a moment. I was working on a small program that needed to be displayed on the screen. Unfortunately, I couldn't see it initially, but now I've managed to locate it. The program is quite essential for my current task, and I had to ensure it was correctly written and visible. It took a bit of effort to adjust the settings and make sure everything was in place, but finally, here it is, ready to be used. This program is a crucial part of my project, and having it visible on the screen is vital for the next steps I need to take. Here we will use a tool setup like this, okay? So a rhomboid. Sorry for the mess, therefore the virtual point is 3. If the rhomboid were an internal one, the virtual point would have been 2. This is necessary for the machine whether you're working in manual mode or ISO mode to manage G42 and G41 for tool radius compensation. Now this part is only for the graphics. We're going to say we're using an external general tool positioned according to the little drawing we see, a 95-degree approach angle and an 80-degree insert angle. Perfect. Now it can calculate the graphics. At this point, let's enter M4, S200, G96 and OB insert. So the cutting data, where we will position ourselves quickly. First of all, G00, X300, Z0. The tool setup is crucial for precision and accuracy in machining operations. The rhomboid shape is chosen for its geometric properties, allowing optimal tool engagement. The virtual point is a calculated reference, vital for determining the tool's path. In manual mode, the operator controls tool movements. In ISO mode, the machine follows instructions. G42 and G41 codes are essential for compensating the tool radius. The graphics section provides a visual representation of the tool path. The external general tool is selected based on material compatibility and machining requirements. The 95-degree approach angle and 80-degree insert angle optimize cutting efficiency. By entering M4S200, G96 and OB insert commands, we set spindle speed and cutting parameters. The G00X300 Z0 command positions the tool quickly to the starting point. EO B X135 EO B insert. Look at what it did. It inserted 3 blocks in this line. Separated by the semicolon, it automatically put them on a new line. X300, I'm raising up for safety in this direction. Z0, I'm going here to X35, but low. What am I doing? I'm getting ready to face my piece, because obviously we're not learning anymore. We're programming now. We need to go down to face our piece. So, G1, X25, F0.3, M8, EOB insert. What did I write? I said 0.3, wrote 0.2, but it doesn't change much for us. I've positioned myself here, I've gone down to 5 millimeters below the hole, turning on the water while moving slowly. Now G0, Z2. And OB insert. X130. Here you are. I position myself 2 millimeters on the edge at the maximum outer diameter of our blank, and now it's time to insert our macro G71. Here, please take a screenshot of this. This is the carefully fixed cycle G71, commented block by block. So now what I need to do is insert a G71 U5 in a step-by-step process. R1 and OB insert. I tell him, look, I'm starting a roughing macro that will have radial passes of 5 meters. Every time I finish a pass, I raise by 1 millimeter and go back. Then I repeat G71 and tell it P10. Q20 shift U0.35 V0.1. U035 V0.1 F0.3 EOB insert. Alright, now I'm going to write a profile. I'll close it between block 10 and block 20. You'll completely rough it out, but you'll plan for the tool that will do the finishing to have 3.5 tenths of overcut in X, and this is an error. It's V0.1. It alters what I'm going to overwrite. I'll leave 1/10 of an overlap in Z, and you'll do all this at 3/10 per revolution. The parameter regarding the RPM is given by M4 S200 G96. Alright, now I'm going to describe my profile. So at this point we say G0X66, which means I'm moving here. However, this G0X166 must be preceded by N10. Specifically, precisely, in particular, as a matter of fact. So, G0X66. N10, what is it? P10. You see that not all blocks are numbered because FANUC doesn't require it, and nowadays no control does either. I'm only going to number the blocks that matter to me. Be careful, no part of the program should ever show N10. At this point, I'm moving on without numbering the blocks. NG42 EUB insert, G42, will be completely ignored during roughing. But will then be used in finishing. I will describe my profile. This F is only for the finishing cycle. I can change the F. Let's continue with X70. C2 and OBI insert Z-20, R4. So this F is only for the finishing cycle. In finishing, I can change the F as many times as I want. The roughing will always be adjusted to the F of the macro. Let's continue with X70. Now, I don't recall if we perhaps need a comma, so let's put it in and see. C2 and OBI insert Z-20, R4. Then we have an angle of 60, so 180. Angle 120, 100, R6, and I'm here, so angle 120, R6, I stop at X100. This point, X100, is crucial as it marks a specific location in our setup. You see that here we don't have any Z reference, which is essential for determining the vertical position in our coordinate system. Let's put in a comma at 180, R5, and hit insert. This action is necessary to ensure the correct sequence of operations. Now the machine is blind at this moment. This means it lacks the necessary information to proceed accurately. Error at 180. I've highlighted this, so I'm altering what I wrote above. The machine is blind here because it knows it needs to move in this direction, but it doesn't know when to stop. This lack of stopping information can lead to potential errors in the operation, which is why it's critical to address this issue promptly. Let's tell him now. What do we tell him? We tell it X130, Z-50, comma, at 105, 90 plus 15, and OB. 3 coordinates. Allow me to build the drawing. Right now I'm going to write N20, U3. And OB, what is it? U3 is an incremental that just raises me a bit. N20 is my Q20. G40, EOB, insert G0, X300, Z300. To avoid an alarm, we add an M30. Let's do our first simulation and see if we have any small errors. That can happen. Simulate. Let's rotate the piece according to our viewpoint. So ISO X and Z in this direction. Let's restart the program and give it the start for the movement. CHFR, which reminds me of the limit. And OB. What is it? U3 is an incremental command that just raises me a little bit, providing a slight adjustment to the current position. N20 is my Q20, which is a reference point in the program. G40, EOB, insert G0. X300, 300. These are specific commands that set the tool position to X300 and Z300, ensuring the tool is in the correct starting position. To avoid an alarm which could interrupt the process, we add an M30 command, which is essential for program termination. Let's do our first simulation and see if we have any small errors. These errors can happen due to various reasons, such as incorrect input or misalignment. Simulate. Let's rotate the piece according to our viewpoint, so ISO, X, and Z in this direction, which helps us visualize the process better. Let's restart the program and give it the start for the movement, ensuring everything is set correctly. CHFR, which reminds me of the limit, is a crucial factor to consider as it defines the feed rate limit, ensuring the machine operates within safe parameters. About this simulator, I'm not copying. Here's the original program. Take a screenshot. I'll tell you about the limitation of this simulator. You see, it's almost the same as what I did. This simulator has a problem. It can't insert an unknown block. The 180 dimension can't be inserted. We need to modify it as if we knew this dimension. Let's creatively modify 180 to Z42A, delete A, and execute our cycle. Simulate restart. See the piece executed. Non-commercial simulators have limitations. We should calculate the exact intersection in CAD. I apologize, but I didn't remember. This floor with the simulator, we can move, zoom, or rotate the piece to view it. Once the profile is done, these blocks tell us how many passes to make, calculated automatically. Visualize the 2D rotation, see all passes made through our macro, start again. All this is determined by G71. Of course, we can't just give a block like that anymore. We need to delete the A and go ahead and execute our cycle. So simulate, restart, and you see that the piece is being executed. You have to realize that these non-commercial simulators have some limitations. In this case, we should have calculated the exact intersection of this dimension ourselves in CAD. I apologize, but I didn't remember this floor. Now, with the simulator, we can move, zoom in, or rotate our piece little by little to take a look at it. So, as you can see, once the profile is done, these two blocks tell us how many passes to make and how to make them, as they calculate them automatically. Let's see if we can visualize the two-dimensional rotation, and you see that these are all the passes made through our macro. So let's start again. You see, all this stuff is determined by G71. So you see that it's going to duplicate the profile in a straightforward manner. Otherwise, we would have had to write xg1x, g0z, xg1xz, g0z in the process. This macro is much more advantageous. The wider the part, you need to remove as we proceed. Let's go back to our program for a moment. Now, for ease and simplicity in our calculations, we'll do it with the same instrument. In reality, we should modify the insert, modify the instrument, modify the station, and use a positive instrument for finishing appropriately. Right now, we're going to do external roughing and external finishing just to follow a logical sequence of operations. In reality, it's best to do all the roughing operations first, and only at the end do all the finishing operations. So nothing stops us from calling for the profile finish between N10 and N20 after we've done a hole, a thread, a tapping, or another internal roughing. We can call it at any time. So at this point we're ready to call G70. So we move to this area quickly, and then we do G0x132Z3 and call the G70 insert. The sequence we are discussing is the final macro, which is identified as P10Q20, P10Q20. This sequence plays a crucial role in the overall process, ensuring that each step is executed correctly and efficiently. Following this sequence, it is necessary to execute the command to insert G0, Z200, X300. However, at this stage, a format error occurs. This error is due to a misalignment in the expected input parameters, which can lead to complications if not addressed. Fortunately, this issue is manageable and can be corrected with careful attention to detail. Once the error is resolved, the system will proceed with the G70 command. This command is essential for the successful completion of the task, as it ensures that all operations are finalized and the system is ready for the next phase. Understanding and addressing these steps is vital for maintaining the integrity and efficiency of the process. Okay, now let's go ahead and let us proceed with our detailed and comprehensive simulation. We will restart and then start. Alright, as you can clearly see, I've done the finishing touches. That's indeed good, so let's do it. Why exactly are we doing this? The reason is that I wanted to show you this too. If we go to insert a T2, which is 0.8, and then move to the virtual point 3. Additionally, this process helps us understand the intricacies involved in the simulation, ensuring we cover all necessary aspects thoroughly. By doing so, we can anticipate potential outcomes and benefits, such as improved efficiency and accuracy in our results. This comprehensive approach allows us to gain deeper insights and make informed decisions based on the simulation data. Same type of tool. So basically, one. We also have the option, with this software, to insert machining colors to clearly tell operations apart. Here, before the X300, let's always call up the finishing tool. Always add comments, M-Force 300G96. Definitely include data related to spindle rotation to find block rotation data is ready. This way you can clearly see what's happening. Restart, start, set to single mode, do as you wish. Press ta-ta-ta-ta-ta-ta, fast, 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 zoom, restart, see finisher. Now, work inside. First step, create tool, take T3, tool correction, enter geometry T3. When you call up a program, always include the data related to spindle rotation and any other relevant parameters, so that if you need to search for the block, you already have the rotation data and can quickly access it with ease. You see, this way you can clearly and easily distinguish what's happening in the process. Here's our machine part, which is now ready and prepared for the next steps. Restart, start, and observe the changes. You can set it to single mode or do whatever you want with the settings and configurations. You see, press da 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 da, fast, 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 and notice the speed and efficiency. Look closely, zoom in, restart, and you'll see the finisher coming in to complete the task efficiently. Now we need to work on the inside, which requires careful and precise attention. What do we do first? Let's create a tool. So we'll take the T3 tool, correction, and proceed. We'll go into geometry T3 and say 0.8 as a virtual point tool. Radius, and here it changes. Here it becomes 2 because it is a boring tool wear corrector. Always that does not interest us at this general moment, but positioned according to the drawing. 2. Angle, obviously, we are using a CNMG, we have to think backwards, but always 95 and 80. Let's change the color here too, and say OK, close it. Let's forget about the M30 for a moment. Perfect. Now I'm going a bit fast, but let's try to be professional. T0303 in parentheses for roughing, and internal finishing is nice, but I need more comments. So insert the block after. It will be a comment. CNMG 2408, 120408. Cutting edge. PM quality 4325 EOB. Let's give our colleague this information when he comes to set up the machine. It won't hurt. M4 S200 G96. Let's reset the RPM. So at this point, we move in the opposite direction. So X30. Let's ensure everything is clear and precise. And ensure everything is clear and precise. And ensure everything is clear and precise. X30Z3. If you want to be more sure about the process, you can approach the task less directly by considering alternative methods or strategies. I'm really speeding up here, which is perfect for achieving efficiency. G71, G71. Here, we always have the depth of cut, and I need to check it. I don't remember, so U3. Here, because it's an internal one, a bit more fragile, R1. With the new G71, I won't be able to use P10 and Q20 anymore, so I'll use P30 and Q40. Be careful this time, I'm leaving the overcut down, so minus 0.35. I'm keeping V the same. I didn't mention it, but I didn't set it. I told you my keyboard with the minus sign gives me a hard time. V 0.1, F 0.25. Now I'm inserting, so I'm positioning myself at NN30X54. I need to do a 2mm chamfer, so X60 0. Insert. Now I'm going to position myself, so N30X 54. I have to make a 2-minute chamfer to the edge of the part. Carefully and precisely using the appropriate tool, so X60 0. X60. Let's also set Z3 here. For safety, just to be sure. G41. I'm going to make the necessary corrections to the width, according to a counterclockwise rotation, and here we go. With G1 and Z0, F 0.25. I can't remember if I used water. M8 would turn the water on, and M9 would turn it off. So I've positioned myself on my piece, and I'm carefully going down to X54, C2, and precisely going to Z minus 20 as I proceed. Comma, R, and here we are. And I'm going down. Here we have the same problem as before. I would go down to a 90, chamfer 2, but I can't do that because the program would generate an error. If I have 34 here, I'll set it to 40. So X40, C2, and I'm inserting the last block Z, minus 73, 73X, 34N. Pay attention because it's important. As it closes, the U profile. X30 I wrote approximately 35, so around 34 and about 40 U. Minus 4. And OB, insert G40 to deactivate the tool radius correction, G0, by using the command in the CNC machine to ensure precision and accuracy. G0, Z100. I'm coming out in Z because I'm inside a hole. Only after that can I set X300, Z300. Now, let's take care of the finishing. For those paying close attention, I made a small modification to the program because some minus signs didn't come out as I said. My keyboard is a bit faulty, for example. The minus Z20 wasn't there, so I fixed it since I had to disconnect for a second because I'm having issues with my home network. To do the internal finishing, we need to position ourselves quickly at this point because the point where it will return. If we position ourselves quickly at a point like this, after finishing the roughing, the machine will return in this direction, so it will cut my program. That's why now we'll write G0, Z3, X30. Then we'll insert my finishing macro with my nice P30, Q40, P30, Q40 insert, and G0, Z100 when we're inside.
even if we know we're already out. We always come back first in ZX200, Z300, and then M5 and M30 insert. If you forget M5, M30 will exclude it. If you forget M9, which is the coolant shutoff, not all machines exclude M30. Now let's simulate. Then we're going to carefully insert my finishing macro, which is a crucial step in the process, with my nice P30 Q40 P30 Q40 insert and G0Z100. This step ensures precision and accuracy. When we're inside, even if we know we're already out, we always come back first in ZX200 Z300 and then proceed with M5 and M30 insert. It is important to remember that if you forget M5, M30 will exclude it, which could lead to errors. Additionally, if you forget M9, which is the coolant shutoff, not all machines will exclude M30, potentially causing issues. Now, let's simulate the entire process to ensure everything is functioning correctly and to verify that all steps have been followed accurately. Our cycle simulates a restart and start. We've already seen this part, and here it's done smoothly on the inside. We want to see it clearly, so what do? We do something like this. We rotate, we work in the X direction, and that's it. Now, let's cancel, start, again, pause for a moment, and cut our piece according to what we need. As you can see, our piece is being machined perfectly. This, as you can see, is the rapid movement at the end. If we press start, unfortunately, it also resets the graphic display. Alright, guys, today we've seen the roughing macro and the finishing macro. If instead of G71 we had used G72, the roughing would have been done in this direction, but our profile would have needed to be described in reverse, meaning from here to there. We would have had to position ourselves at this point and describe the profile in this direction. And G72 would have done the same, but from top to bottom, and internally it would have done it from bottom to top. Usually G71 is the most typically and frequently used, but if you have discs with excess material in this particular direction, you can also use G72. It's a bit more delicate and careful for holding the workpiece, because obviously, clearly, if we push against the spindle and not across it, we have more safety. I will not explain G72 in detail. Instead, I'll show you. This is the famous and well-known diagram. Let us see if I have it available here too. Here are the detailed diagrams of the excess material for roughing compared to finishing. Take a nice clear screenshot of this. This is the actual real program that should be entered into the machine without the simulator bug, which doesn't allow two angles in a row. This is G72. Here's a practical example of G72. Take screenshots so you can keep these as exercises at home for future reference. And this is G73. I won't explain it because I find it to be a total nonsense. This macro de ripi. This is basically the repetition of the profile. If you have a mold, it allows you to do it many times. However, during roughing, there's often a risk of breaking the tool, so it's advisable to use molds the way I see them, especially since they are already pre-shaped. You should rough them out in ISO to avoid unpleasant issues. So you have to work point by point and do the various roughing before the roughing operations, meaning from X plus to X minus and then for all diameters. Because with this macro, you can run into a lot of troubles. This is an example of the macro, so I'll leave you everything you need to study it, but I won't explain it to you. I've never used it. I've made quite a few molds in my life. Well, when the going gets tough, the tough get going, and I have to say I'm also struggling to convey everything I want. I hope I've managed to do it this time too. If you have any questions, feel free to ask them in the video. I can't respond to everyone, but I really enjoy seeing a lot of participation. There are also some who occasionally correct me because I'm not infallible and I don't prepare the videos. Those who have been following me for a while know this, because the beauty of mistakes is being able to discuss them together. I greet you, wish you a good day, and I look forward to my next video. Bye bye. I hope I managed to do it. If you have any more questions, feel free to ask them in the video. I can't respond to everyone, but I really enjoy seeing a lot of participation. There are also some who occasionally correct me because I'm not infallible and I don't prepare the videos. Those who have been following me for a while know this, because the beauty of mistakes is being able to discuss them together. I greet you, wish you a good day, and I look forward to my next video. Bye bye.